Hey, thanks a lot. So what I try to do in this talk is to give you an overview of the ML applications in the three-sided marketplace that we operate at DoorDash, and then basically talk to you about the things that we don't talk about a lot, which is like how LLMs are being used as features inside traditional ML models rather than on its own. And that is where we are finding a lot of value. So I want to walk you through sort of the journey that we're on. But before we go there, obviously, I hope everyone has used or know about DoorDash and you know what we do. Maybe you know DoorDash mostly through the restaurant food delivery. And I was just like wondering if everyone ordered DoorDash food right now, it'll be a chaos, right? So let's not do that. But in the quest of providing you, the consumer, with anything that you can buy from your neighborhood, we have been expanding beyond restaurants, and that is what New Verticals is all about, which is the organization within which my ML organization lives, and I head up that ML organization. And in that quest, we're expanding to convenience, grocery, retail, flowers, pets, alcohol, beauty. So you name it, we will deliver it, right? And we want to capture all the shoppable moments, and we want to make this, a neighborhood of good, as we say internally. In that transformation, when we go from a restaurant delivery to a New Verticals, which opens up the whole e-commerce space, it actually brings in a paradigm shift in the types of ML that we need to do, right? And just like simply think about a restaurant, they may have 100 things on their menu. If you think about a large, store like Target, they might have 100,000 SKUs, 100,000 items. And then this difference, immediately changes a lot of technology that needs to be deployed for ML and AI for the New Verticals. But if you zoom back out a little bit and look at the three-sided marketplace at DoorDash, we have sort of three vertices of this triangle. So we have the consumer at one end who is looking on the app and basically trying to decide what they should buy or which order they should place. In the case of grocery store, they're also thinking how to build their basket. And this is where, the typical search, personalization, these types of ML are applied, right? So essentially, if you visit a grocery store, we should be able to know that, you probably are a vegetarian, so there's no point in showing a meat aisle to you. If you're searching, we should be able to know, we should know that what type of milk you like. Even if you type the simple query milk, we should be able to give you the 2% or the whole milk that you like, right? So that's personalization and search. And then if something is running out, we also want to show you substitutions. That's where also ML comes in. So this is between the consumer and the store. And then once the order is placed, the dasher goes to the store and does the shopping for you. That's the difference from the restaurant use case again. The dasher goes inside the grocery store or the alcohol store. They need to find the thing that you ordered. And that's why very accurate product information is key. So the product knowledge graph that we're building, which is at an e-commerce scale, needs to have all the key attributes extracted and presented both to the dasher and the consumer to make good decisions. At the same time, we're also looking at deploying AI and ML solutions in helping the dasher navigate the store better, faster, so they can do the shopping faster. Between the dasher and when the dasher picks up and then basically delivers the thing, there are a lot of algorithms like dispatch algorithms, batching, how can I batch multiple orders on a dasher. ML is also determining the shopping efficiency, as I said, how they navigate the store, the pay that the dashers get based on the efforts they put in, and then also there is this whole supply and demand. So depending on when the hotspots are, we also need to rebalance the supply of the dashers on the streets. So this is all the ML applications. It's not possible to go through it in 20 minutes. So I will only, talk about the two areas that we are finding a lot of use of LLMs. One is personalization and search. The other area is building our product knowledge graph. And this is one slide that I want to take you away with you, which is traditional ML has been there for a long time. We've used this for personalization search and everything for a long, long time, well understood space. And the open circle here is the generative AI part. We don't know where it's going. Every day new things are coming out. But Where the magic is happening, at least from my vantage point, is where these two overlap. So basically where you can actually use Gen AI as an assistant or a feature inside a traditional ML system. So I'll talk about personalization search and knowledge graph. I'll set up the problems first and then go into the LLM applications. So personalization, as you know, if you're going to a grocery store inside DoorDash, I need to know your tastes and preferences, your habits and idiosyncrasies. Do you always order alcohol on a Friday evening? Dietary lifestyle restrictions are also very important. As I said, if you're a vegan or if you're on a keto diet, we need to understand that. Your brand affinities, some people like Strauss milk, some people like Clover milk. We want to understand those. And at the same time, we don't want to pigeonhole you into your tastes. We also want you to help, discover new items. So there should be enough serendipity in this app. And balancing all that is being done through ML. And the first thing, obviously, is relevance. So the things need to look relevant. So we do a lot of ranking on the pages, like when you go to the bakery category, then all the things that only matter to you should be at the top. Similarly, when you have things in the basket, we have ML algorithms that are suggesting complementary items to your cart. And then buy it again is also ranked by what you're likely to run out of today. And then there are deals and promotions that are also highly personalized, right? So these are some of the surfaces where we do a lot of personalization. But if you overdo it, you can actually end up with this kind of a screen, which is from a simulation, which is like this person really likes carrots, right, in the center. So their whole page became just carrots, right? So and this is something that classical personalization always deals with, is like over-personalization needs to be balanced with diversity and serendipity, right? So there's always exploration, there's diversity that you need to slap onto the personalization, right? And the other thing that we also need to do to have the experience be even more personalized is to be able to respond to explicit preferences. If you tell me you do not drink alcohol, there's no point in showing you alcohol in the app, right? So basically, explicit preferences need to be both collected, where LLMs can be useful because they are conversational, and then they have to be acted upon. That's how it goes back into the traditional ML stack. Search, on the other hand, is a different beast. So search at DoorDash, as you can imagine, is multi-intent, multi-entity type, geo-aware. So if you're searching for apple, you might be actually searching for the fruit, or maybe you're actually searching for apple juice, or store named Apple Land Market, or you're probably going to search for an Apple charger. So we need to understand as you type what are the different intents that this query is going to funnel into. And this is also where LLMs are becoming more and more useful. And then beyond understanding the intent, search, as I said, needs to be personalized, right? So basically, if you search for a simple query, milk, the same milk that I like may not be the milk that you like. So we need to understand which one should be ranked at the top. I give the example of the ice cream. Like ice cream, really we see very, very polarizing tests between people. And so it needs to be really highly personalized. And if done correctly, search can be, personalized search can be really delightful, right? So as I said, this person's searching for whole milk, very specific, but we understood on the right-hand side that they actually have a brand affinity, and they also all prefer organic milk. So that one gets ranked to the top. But if you, again, overdo it, this can happen. So basically, this person is searching for blueberry, and they also really like yogurt. But because the search intent can be a little bit, fuzzy, because as they're typing out blueberry, we might think that they're probably going to type all the way out to blueberry yogurt, and then because they have already purchased many times the yogurt, you can have over personalization again here, right? And this is a case of showing something that is semi-relevant to the query, not exactly relevant. And these relevance labels usually came from humans, and then you train an ML system on it. But now we're finding that we can scale that relevance piece out with LLMs very, very efficiently. Product knowledge graph, on the other hand, as I said, when the dasher goes to shop for you or the consumer is making a decision in the app, we need to show all the different attributes that define a product. So it's like brand, the size, the unit size, the count, flavor, think of a bottle of wine, you need to know the vintage, you need to know the grape varietal, you need to know, the winery and all those things. So these needs to be extracted at scale and in a structured format, so I can then use it in the downstream applications. This is again where we're finding, human in the loop, AI, ML, to be very, very useful, right? So I will spend because everyone wants to talk about LLMs today, I'll spend still one slide on traditional ML, and then go to the generative AI part. So traditional ML typically nowadays is done through representational learning, right? So basically, you have your consumer, you have your item, you have these two-tower models where you're learning item embeddings or consumer embeddings. In the case of search, you're learning query embeddings, right? And these embeddings then become inputs to other algorithms downstream. So I can do things like when you search for eggs, I know what type of eggs you like. When something is running out, we can also build item-item similarity embeddings. So we can say, this, whatever this is the capers that's run out. I can actually say, this other bottle of capers is a good substitute. So the zoo of models is like the typical ML zoo that we have. We have, DC and V2 for recommendations. We have also leveraged graph convolutional networks for our growth applications, where basically, we kind of want to anticipate who is the consumer who is going to try grocery next. And then obviously we have, the old school BERT, and then fine tuning it. And then DLRM is deep learning based recommendation models. So this is the standard zoo that we use very, very effectively. But as I said, the magic is happening in the overlap of the two. So where is GenAI becoming more and more useful for us? So basically, query intent understanding. So as you type Apple, we want to understand what are the different intents that this can expand into. Product knowledge graph construction, I already told you how we're extracting attributes, but also there's many, many other applications in that space. Item recommendations, right? So all of these traditional ML algorithms, they learn from consumer engagement. So if you have a scenario where no one has bought something or no one has bought two things together, these substitution type algorithms, they're like flying blind. So it's a cold start problem. So if no one has bought on your app shoe and shoe polish together, there's no way for the ML model to know that this is a good complementary item. But LLMs has this world knowledge, so you can actually go and bridge that gap with LLMs. There's the obvious use cases like dialogue type support, where it's conversational recommendation systems, conversational search. And then the thing I also talked about is search relevance. So getting relevant signals for search is another area that we're finding a lot of usage. You can do inspirational things with in the personalization space. So given what's in your basket, right, we can basically figure out what are some amazing recipes you could make if we only had these missing ingredients. So that's a great way to nudge the consumer to add more things that they might be forgetting and they might need to round out a nice recipe. And this is, one example of an idea where, GenAI can be used very, very effectively because it has so much world knowledge out there. Like looking at things in your basket, it can recommend 5, 6 different recipes that you could make. Understanding query intent in search, again, so basically someone's typing ragu, you need to understand through all our things that this is not like, someone both based on their previous, search history as well as this search term. We need to understand that this is an intent for a query for a pasta sauce and probably for the brand ragu. And to train these kind of models in the past, we used to need a lot of annotations, and that's where, as I'll explain, the LLMs are becoming very, very useful. So we're improving training data quality at scale, and also in the tail queries that do not happen very, very often, right? So very long queries to understand both the intent and also the relevance of the item to the query. LLMs are becoming more and more important. So some of the things that we're doing, some of the challenges we're facing, we're doing this is, evaluation at scale. We have figured out several ways internally, and then there is fine tuning and domain adaptation. New technologies are coming up every day. We have been using LoRa and QLoRa very effectively in many of our applications. There's obviously RAG because we need to be able to like pull in things from our own catalog into the prompt, and chaining LLMs and agentic workflows. So these are all in the works, but basically going back to the applications again. So automated relevance labels for search is one area that not only us but many other companies are finding a lot of usages of LLMs. So this would actually solve that case that I showed, which is like this person who really likes yogurt, search for blueberry. We will stop showing or push down these semi-relevant items because now we can actually have a label from an LLM which says, Chobani yogurt is semi-relevant to the query blueberry, whereas the fruit itself is more relevant. And these types of things used to be much, much harder to do in the traditional ML world. Product knowledge graph building, like we're trying to extract all these different size, flavors, vintage, and all these things from the product. And typically these, as you go to a new category, say, you started like doing extraction in alcohol, we would need massive amount of annotations to train our extraction models. These are like named integer recognition type models, but that becomes a bottleneck, right? You need to pay a lot of money. You need to also wait for the annotations to come back. Whereas what we can do now is like with few very, very high quality golden annotations, you can actually use that as a seed and interrogate an LLM to get silver annotations, which are not super high quality, but good enough that you can actually go back and fine tune another LLM with it. So use a high quality LLM for generating more labels and then use it to fine tune a fine tunable LLM or an open source LLM. I wanted to open up a little bit of like how we're doing this product knowledge graph building. So, we get raw data from a merchant, which is very like sometimes unstructured, sometimes semi-structured. We need to define some templates that are according to our own style guide internally that our taxonomists on our team define. But then once you have these two pieces of information, then you need to extract and fill in the blanks of that template, right? So the output that we need is what's the brand, what's the noun, what's the flavor, what's the preparation type. And this type of things were very, very expensive to do before and very, very complex. But with fine-tuning LLMs, with lots of human annotated data, we are finding, really high precision and recall of these types of in these types of applications, which has completely changed the game in the sense that, both in terms of the throughput of these systems and the amount of money we used to spend on humans on getting annotations. These have completely changed the game. This one, again, is an example of where we're using RAG, the thing that I was talking about, to fine-tune a different model by using a very high-quality model. So the example here is like, there's different types of tequila and how you train the model to understand that anejo and reposado are two different types of tequila, right? So basically, you need those examples to be brought into the prompt and then fine-tune the model based on those examples. But to do that first step, you can actually do RAG, which is ANN based, and then bring in more examples from a golden data set, enhance the golden data set. So now we have a silver data set, which is much, much larger, 100 times bigger, and then fine-tune the LLM, and then the precision just shoots up like spectacularly. Also, looking back at the catalog, which has been built by humans, we have like hundreds of thousands of items that are in the catalog, and many of them are wrong. Because when we were building the catalog, it was a manual process, and humans make mistakes, right? So for example, this example, right? If you look at the image of this thing, it does not say honey smoked, but the item name says honey smoked. And now the consumer is confused. Is it honey smoked or not? And if they order it thinking it's honey smoked, they maybe will not get the right item. So we need to go back and fix all these errors that is existing in your product knowledge graph. And that's again where LLMs are super useful because many of that information is in the image. So this is where multimodality is key. So we're using multimodal LLMs to actually solve this use case very, very effectively. So I will just end with some of the next stages of exploration that we're thinking. So one is domain-specific LLMs, and I touched upon that. So what we're finding is in this product knowledge graph building, as we point our technology to different, categories of products, like beauty versus alcohol is very, very different. So in the olden days, you would have to retrain a model from scratch. But nowadays, what we're finding is you can actually take the base model and fine-tune it and make it more domain-specific in a much shorter time, right? And because there are certain things like size, certain things like brand, that is common across all these categories. And then there will be certain things in beauty, like shades of lipstick, and certain things in alcohol, which is like alcohol percentage, which are very, very different. But we don't need to build like separate models, rather fine-tune the same base model on different use cases. So all these domain-specific LLMs are becoming more and more important. Multimodality, as I said, is super important because many of the products like we carry, and let's say you want to ascertain if something is keto or something does not have nut or allergens, you have to read the back of the package sometimes, and that can be done very effectively with the multimodal LLMs today, right? And so as we're integrating LLMs into our work stream and into our traditional ML models, we have to obviously balance latency, quality, cost, and this is something we can have a different chat on. But what we're finding to be really useful is being able to fine-tune open source LLMs, and often they're actually beating or at par with paid subscriptions. Better integration, right? So one other thing we're looking is like in-house LLM models and ML models, as I showed, how to integrate them better. And I gave you some of the examples, right? So for example, a substitution model where we don't have any engagement data, you can actually leverage LLMs to create item-item similarity or item-item recommendation labels, and then go back and train the traditional system. Agentic integration is something, again, we are looking into, right? In some cases, there's a package of something you don't know if it's like keto. The agent can go and do a Google search for you and figure out if this is actually truly keto. And then, more use cases, natural language search, right? So you should be able to search DoorDash by a normal natural language way, which could be conversational. Another piece that every company struggles with is cold start. Cold start of consumers or cold start of merchants. So when a new consumer comes to a grocery store, we don't know anything about them. How do we make their sort of experience feel more personalized from day one? So that's where we're actually looking into some ideas of making that first few sessions more conversational with an LLM behind the scenes, so we can learn a lot about the consumer in the first few interactions and then like jumpstart their personalization. So with that, I will thank you. Thanks for listening, and I'll take some questions. Thanks. There's one there.
Hi. I think you briefly touched on it, but wanted to know a little bit more about the canonical taxonomy.
Yeah.
Right? Because maybe Safeway has organic bananas under health food,
Yeah.
and Target has us under just fruit. So that canonical taxonomy that you have to map all these items to, how do you go about that?
That's a very good question, and we have definitely been bitten by that. So yeah, I think to repeat the question, like every merchant has their own taxonomy, but DoorDash has its own, and you have to have like a taxonomy is something that has to be so foundational because we use it in every single ML algorithm. So you cannot afford to have different taxonomies for different merchants. So we have to have that mapping step, as you said, right? So this is actually done by an internal ML system. That's a reclassifier of an existing taxonomy. And that is where the thing that I was talking about is like getting the labels so that you can actually do that remapping better used to be a bottleneck, right? So now through LLMs, we're actually bridging that gap quite well, right? And then you can also teach the sort of remapping of the different taxonomy paths to the LLMs, which also helps. But at the end of the day, it's actually a good old classifier model that sits at the end of it. When it finds things that are harder, then it goes to an LLM. So it's kind of like a waterfall model that we have found to be very useful here.
Thank you.
There's one there.
Hi, I was wondering if you guys have quantified internally the impact of either higher productivity or lower costs around correcting inaccuracies in the catalog or tagging items. Question on the economics.
Yeah, of course. I mean, that's a big area for us. Like, so it's hard in the sense like the catalog inaccuracies show up in so many different ways to the consumer, right? So essentially, you have to have very careful measurements of like what the impact of those inaccuracies are. And typically, the way you go about is as like through pre-post analysis. So after you fix it, you see how much things change. And through those, we have figured out like what are the biggest inaccuracies to go after first. Obviously, like it's actually big. The impact is really big, and that's why we're putting a lot of resources into this problem. But I cannot talk about the actual numbers. But yeah, we've definitely done it, and that's what's motivating this work. Cool. I think that's the last question I could take, or yeah. One more? Okay, just one. There.
Hopefully mine's pretty simple. I love the simplicity of the idea of using an agent to go search Google to come back with, yes, it is keto. Have you found a way for that to plug back in and automatically correct or update your records or your elements?
Yeah, I mean, like anything that I described, right? So wherever like there is a model involved, be it agentic, non-agentic, right? So basically everything comes back with a confidence score. If the confidence score is high enough, then it automatically updates the record in our backend systems. If it's semi-confident, then it goes to a tool where a human looks at either the output or some other options that the model gives that, is it the right thing, choose between the three. And that's the human in the loop system. And once the human does something, we actually feed it back into the ML, because next time it learns how to do better. Cool. Thanks a lot.